Hey, yo, Trayvon.
If you say, teach us something.
Teach us objective 112.
Okay, there we go. All right, so starting last week, and maybe a little, it's basically last week, maybe a little bit before, we started talking about right triangles a lot. Right triangles is going to be about 40% of your end of the year test. Now, what you're learning today is called right triangle trigonometry. And that big long word sounds scary to a lot of students. Because you know that's an advanced math class. There's trigonometry is next hour. But it's actually what you do in here with trigonometry is not that hard. And it's really, really important. So we're learning it today. And we will probably see a lot of it on your bell ringers and stuff moving forward. But let's look at something we already know when it comes to right triangles. Solving this problem. When a problem like this pops up on your EOI, what are you going to use to fix it? To find the answer.
Pythagorean, yeah.
There you go. Pythagorean, yeah. Which is a squared b squared c squared. So you have your triangle, you have both legs, so how would we set this up on our equation?
12
squared
plus 41 squared
equals x squared, or c squared, either one. 12 squared plus 41 squared equals x squared, and 12 squared plus 41 squared equals 1825. 1825 equals x squared. All right, 1825 equals x squared, not 1825 equals x. How do you unsquare your x? Square root. Square root it. Square root both sides. And squares and square roots do what? Cross it out. So really the square root of 1825. Second square root of 1825.
42.7.
So 42.7 or 43. Either one is fine. 42.7 is x. Alright, so a squared, b squared, c squared. When you got two sides, and these were two legs, you just go a squared plus b squared equals c squared, square root, figure it out. That's the Pythagorean theorem. That's the first part of right triangles. This is what you're going to use trig to do. And we're not actually going to do this today. This is just what this is the whole point of us learning trig. Today's is an easy introduction. This is the picture you're going to start working on. Now, how many sides did they give you?
3.
Now, how many sides did they give you?
Oh, 1.
Just the one. And before they give you the 2, and you can find the third out with a squared, b squared, c squared. When it comes to trig, we're going to solve problems where they only give you 1 and they want 1. Now, they are going to give you one angle as well. It could be this one or that one. It doesn't matter. But then they're going to give you one and they're going to want 1. And we're going to be able to figure this out. Now, today we're not. But the whole point of right triangle trigonometry is to be able to figure out what this problem is. All right, go ahead. Go. Okay, so find the second page up, which is the one that has examples 1 and 2 on it.
Wait, you didn't show us how to get that X.
No, like I said, we're not gonna find that X today. You're gonna find that X tomorrow.
How did you get so backwards?
What in the world are you doing?
I know. I'm gonna go fix this before 5th hour or something.
What?
That's not fair.
Oh, why
That's not
we
fair.
You don't
see
fix
where
the
we
whole damn-
stand.
you
I
do not
just
fix the-
realized it as I handed them out. I was like, this is all out of
He's
order.
saying 5th hour isn't smart enough to figure out.
Oh yeah, they would be so lost. They wouldn't even find the first page. They'd be like, this is the first page right here. No. The back page is the first page, guys. Listen. All right, so for objective 12, and this is what you just asked. We aren't solving for x. We are not trying to find a side on this objective. All we're going to do is learn what sine, cosine, tangent are, which they are ratios, and we're going to find them, and that's it. But trig will help us solve that side. All right, so here's our main three. Now, sine, cosine, and tangent, they're ratios. Sine means opposite over hypotenuse. So you just OPP for opposite. Sine is opposite over hypotenuse.
Is it POP or OPP?
Cosine is adjacent over
I'm on
hypotenuse.
the wrong page, God.
Find it. Now it's your first
I
page.
got it.
Tangent is
That's HY.
opposite over adjacent. Now it's important to remember these three ratios. And it's kind of, you go, well, how on earth? I've got to remember the midpoint formula, the distance formula, the slope formula. I got to remember y equals mx plus b. And now I got to remember these three ratios.
And Y1
So
equals...
what we have is an acronym, which is really good for memorizing long stuff like this. I don't know why it's
That was mine.
Yeah.
was,
Oh,
no, that was a
oh,
watch.
okay. That was the watch.
It's
Tell you what
11
time it
o'clock.
All right,
You're close.
I'll try to speed this up. All right, so the acronym that you need to remember, which is actually just a cheat sheet for the trig, is called SOHCAHTOA.
So
And you gotta get the pronunciation right. So ka toa. SOHCAHTOA. SOHCAHTOA.
Nope.
So you'll hear me say SOHCAHTOA a lot. That's how we'll communicate that. If you're like, how do I solve this problem? Like, that's a SOHCAHTOA problem. SOHCAHTOA. Because sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent's opposite over adjacent. So when you go to do your EOI, other than, you should have a squared, b squared, c squared down, you might want to write SOHCAHTOA as soon as you get in there and get that blank paper. Because this is a cheat sheet. Sine's opposite over hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. Now, we're going to go straight into the examples and see what I mean by this opposite, hypotenuse, and adjacent. All right, here's a triangle. It says find cosine x. Find cosine x. Now, locate x is right down here. Here's x. It's on this angle. In trig, you're always going to be coming from one of the acute angles. Now notice, every right triangle has a right angle and two acute angles, here and here. We're always going to be coming from either this one or that one. It changes everything if you're coming from this one or that one. We're coming from this one today, on this problem, because the x is down here. It says cosine x. What ratio is cosine?
Adjacent over hypotenuse.
Hypotenuse. We're making a fraction adjacent over hypotenuse. Now, let's label these three sides though. All right, from here, from this angle. All right, do you think that this one is opposite adjacent or hypotenuse? First off, is it the hypotenuse?
No.
Heck no. The hypotenuse is Big Daddy C up here. That does not change. This is the hypotenuse.
Carlos.
So, which one would be more adjacent? This 8 or that 6?
8.
8. Adjacent means what?
Next to.
Next to. That 6 is not next to. So this is your A, and this is your O for opposite. So if we want adjacent over hypotenuse, so cosine
We gotta use your tab.
is adjacent over hypotenuse.
Oh.
So what is our adjacent?
8.
And what's our hypotenuse?
10.
So 8 over 10. Now you're not going to see 8 over 10. Because 8 over 10 is a fraction that reduces, but 8 over 10 is right. 8 over 10 reduces to what?
4 over 5.
4 over 5.
Is that the answer though?
And 4 over 5 is the answer.
Okay. So what are we using these buttons for?
That's what we're going to use tomorrow when we learn to actually find missing sides. You need to know the ratios though.
So this is the easy part of it.
This is
Dude, I
the
can get an adjective today.
this is the pre part here. All right, here we go. What are we trying to find on example 2?
Same thing.
Except for this time it's
Sine.
sine. Now the angle's still down here on the ground, but label really quick. This 4, is it an O, an A, or an H? A. This 3, an O, an A, or an H? O, and what's the 5? H. Now sine in our SOHCAHTOA is supposed to be what over what?
Opposite of hypotenuse.
So it's 3 over 5.
Sine is opposite over hypotenuse. So right here, this is notes. So on your notes, which this is, write sine
I do that.
equals O over H. You don't have to even do the OPP. O over H. What is the O?
3.
What is the H? That doesn't even reduce. That's the answer. 3 over 5. Opposite over hypotenuse, 3 over 5.
Okay, so we're going to the next page after that.
So find yourself
Example 3.
example 3.
Hey, pull that up off here, man. I got this shot from chair.
Let him do it.
Like, I'm not even gonna hesitate. I'm just gonna give it here or shoot it.
That was beautiful.
That was the worst shot ever.
Oh, I still top it. I still had one that hit the green tub over there. So,
Wait inside the green tub.
yeah. And I counted it because it went in the tub. All right, here we go.
You can't count that.
I didn't say if I was shooting for the basket or the green tub. I was like, I was
I
gonna make the paper go in
door.
something.
I'm shooting over there by the door. For the
I was
door.
shooting. Shooting for the door, I hit the door. I was shooting for the wall, I hit the wall. Okay, we're trying to find what?
The cost.
Now, do you see the letter next to that cost?
Yes, the B. Which is B.
Understand that that changes everything. You are not coming from the ground this time, you're coming from B. So let's go do our labeling from up here. Now, here's the one thing that doesn't change. Big Daddy C does not change. 17 is going to be what letter? Hypotenuse. No matter where you are at in a right triangle, you do not change the hypotenuse.
15's A.
But your A and your H change.
No.
What's adjacent to up here? 8 is. There's your A. And then opposite means the farthest away side from here.
15.
Oh. Now, we're trying to find cosine. Cosine is what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So what is my adjacent?
8,
8. What's my hypotenuse?
17.
17. That is not going to reduce. That is
The answer.
the answer.
But what's so different about the B?
What is different about the B?
That's where you start from.
The hypotenuse doesn't change, but your A's and O's change.
Okay, I got you. Stop right there.
You got it? Adjacent has to be touching the angle that you're talking about. All
No further.
right, here we go. Let's go down to the next one.
All right, let's get her done.
What are we trying to find on the next one?
Hey, this one comes from the ground.
This one does come from the ground, right?
We're looking for the sin.
Sine A. Tell me what ratio goes with sine. Sine is what over what?
Opposite over hypotenuse.
Sine goes opposite over hypotenuse.
Do this lesson.
So what is my opposite? Is it 3, 4, or 5?
3,
3.
Opposite is there. What's my hypotenuse?
5.
5.
5. So I go 3 over 5.
Enter.
That is it. Does not reduce.
Hey, this lesson is a sin. Boom.
Shut. Sin.
No, sin.
Is a sin?
S-I-N. This lesson is a sin. Like, I don't even do this
No,
anymore.
Bobby. It's not funny.
Well, Mr. Jones made it awkward, but it was a
I made it awkward.
Yeah,
It
was
wasn't
like,
I got
like,
it.
sin.
I was trying to help make it funny. It was not really, there was no help to it though. Okay, sine B. Tell me, where are we coming from? What angle?
At the top.
The top changes everything,
So.
except for you, you're H. So, from up here, is this an A or an O? An A.
Opposite over hypotenuse.
Now I want sine. Write this down. Write this on your notes. Get used to getting these ratios down. Sine is what over what?
Opposite over hypotenuse.
15 over 7.
What's my opposite?
15.
So it's B.
15 over 17.
That's opposite. Can't reduce.
15 over 17. If you said 8 over 17, you just did cosine. Don't say 8 over 17. Opposite over hypotenuse. 15 over 17.
I fear this one.
That's a lot. That's 5 examples of sines and cosines. Sines and cosines. Sines and cosines. Coming from the ground, coming from the top. Coming from A, coming from B. You will not see tangent on here. But tangent's important. So I want to do one example of tangent.
Give it to Emily.
Give it to Cooper.
Give it to Emily.
1, 2.
Cooper, all the way back here right there.
Ooh, Coop's good. Coop's
He's
good.
like 5 foot from the freaking trash can. That's
5 foot.
Bobby probably
That
wouldn't
is 6 foot at least.
Oh yeah, 1 foot.
6.5 foot. 7 foot. It's 12
Sitting
feet.
down too. Oh yeah, sitting down.
Sitting down. And with the pressure on. No.
This is my work paper. What are you talking
No.
about?
Okay, here's tangent. You won't see on this objective, you won't see tangent at all. But you need to know it. Tangent's opposite over adjacent. It's the TOA. OA. So let's look at this problem, and we want to come tangent A. Angle A is on the ground, angle A is down here. Tangent is opposite over adjacent. Opposite over, it's the only one that doesn't have the hypotenuse in it.
7 and 24.
So it is 7 over 24.
Because the 24 is
Now,
a little bit bigger.
that's tangent A. What I didn't put on here is tangent B. Think about what happens if I said tangent B. What would my opposite be for tangent B? 24 over 7. So if it's tangent B, I get 24 over 7. If it's tangent A, I go 7 over 24. Always opposite over adjacent. Now the biggest important thing to remember on the day, we weren't solving, this is an easy objective, you're not solving, but you need to start remembering the cheat sheet. What is the big word that is your cheat sheet? SOHCAHTOA. It's S, C, and T, but you got to get your O's and A's in there right. So is S, then what? S-O-H. So. Ka is C-A-H, and TOA,
T-O-A.
Is the
T-O-A.
answer this
That is your cheat sheet. SOHCAHTOA, spelled right. Have it written out. Write it several times when you go to do these things. SOHCAHTOA, 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 so that you have it, you have it memorized, and you have those, the order. Now, beginning with objective 113, we're going to actually start solving to find an unknown length in a right triangle when we're only given what information?
One side.
One side and one angle. That is what's coming up next. You're going to give one side in a triangle, and you're going to be asked to find another, but they will give you one acute angle as well. That's what we learn tomorrow, and that's SOHCAHTOA. I'm going to put that exercise on everybody who hasn't done it yet today.